Now we will work with proving angle relationships, and we're going to start module 3 at 3-6. We skipped the first half of this module because it is not technically a Tennessee standard. It goes into a lot of proofs, which we don't need to go into, definitions, different things, but what we're going to focus on, the definitions that we need, the properties that we need, the relationships that we need, and that begins at 3-6. We're going to see things, theorems. Theorems are things that you can prove. We've worked with them in the past. If you see statements like postulates, and I don't really want to worry about the difference between a theorem and a postulate, just think of a postulate as a true statement, and we can use it and then work with it, using it as a definition or a formula and so forth. So, beginning with here, it talks about the protractor postulate. Thinking about a protractor, it's just saying that every angle has a measure that is between 0 and 180 on the protractor. The addition postulate, angle addition postulate, just like when we used it for the segment addition postulate, it's just saying D is in the interior of ABC, and I drew it over here. D is in the interior of ABC. If and only if angle ABD, which is angle ABD plus angle DBC, right, that is going to be equal to the whole thing. So it just says, hey, these two little angles, when we add them together, is equal to the whole angle. And then supplemental theorem, thinking about that, if two angles form a linear pair, then they are supplementary. Well, by definition, a linear pair forms a straight line, and then two angles that add up to a straight line also add up to 180 degrees. So we could say, yes, that linear pair is also supplementary. And then complementary, if the non-common sides of two adjacent angles form a right angle, then they are complementary. Yeah, sure. We have this right angle, and then if I have the same thing here, and we'll just call this E, F, G, and H, then again, this angle plus this angle equals 90 degrees. They're complementary. Okay, so just understanding the definition. So we're not going to necessarily worry a lot about this process right here, but we want to be able to think through it and use our definitions. So really, I'm going to zoom in on the picture. We'll talk about things that we can understand, and I'll probably just go with it from there since you do have this information in your notes. Okay, so example number 1. It says, what is angle measurement 3 if angle measurement 1 is 23 degrees? Hold on, let me just write that in here. 23 degrees. And the measure of angle ABC is 131, and this entire thing is 131 degrees. Well, I should be able to look at this, and I'm trying to find out this, right? I should be able to look at this and say, okay, if all three of these angles added together, this plus this should equal 131 degrees. I know that angle 2 is going to be 90 degrees because there's a right angle there, okay? So then the only thing is left is this unknown value. So I can just simply say, well, I've got 23 degrees plus 90 degrees plus some number is equal to 131 degrees. And now I can solve and I can figure that out. I can, that's the stuff that I know. So let's see here. I'm going to subtract 113 from both sides. And then therefore x is going to be equal to, 18 degrees? And there we go. So we just did that, 18 degrees. And it said, let's see here, did it tell me choose the reasons that provided? So we basically did a lot of this just by understanding our definitions of the angle addition postulate and the right angle. So being able to use the information that we see and solve. Okay, here, check. This is, how do we check our knowledge, right? It says, what is the measure of angle 3 if angle 2 is 26 degrees? 26 degrees. And I wrote over here too that angle 2 and 3 are complementary. We know that because if this is 90 degrees, we know that this is 90 degrees, so angle 2 plus angle 3 equal 90 degrees. So angle 3 should be 90 degrees minus 26 degrees, which equals. Simple enough. Or if you needed to, you could say that, again, angle 2 plus angle 3 is equal to 90 degrees. Angle 2 is 26 degrees. I don't know what angle 3 is, and that is equal to 90. Therefore, subtract 26 from both sides. Go ahead and get rid of that. Subtract 26 from both sides, and x is equal to 90 minus 26, which is 54. So angle 3 is 54 degrees. So just being able to use the terms that we've discovered in the past, and we continue to work with them. And then here looking again that 4, 5, they're a linear pair. Okay. Come over here looking at this. Yeah, sure enough. They form a straight line, so I should know then that angle 4 plus angle 5 should equal what? Should equal 180 degrees. If angle 4, find what is this. If angle 5 is 2x, if angle 5 is 2x and angle 4 is x plus 9. Okay, well, just do some substitution. For angle 4, I have x plus 9 plus angle 5 is 2x, and they are equal to 180 degrees. Now all you have to do is combine like terms and solve for the value of x. I have 3x plus 9 is equal to 180. Subtract 9 from both sides. 3x is equal to 100 and I hope 71. And then if you divide by the coefficient, x should be equal to, let's say 57. 57. So if x is 57, it said find what is the measure of angle 4? That should be 57 plus 9 is equal to 66 degrees. And that's just using our definitions. And our definitions in this class are generally just formulas that we can now fill in the information that we know and calculate what we don't know. Okay. Here again, just thinking about May-Lin, complementary and supplementary angles, looking at the image, things that you immediately know is, hey, that's 90 degrees. It's a right angle. I should be able to look at that and say, hey, angle 3 and 4 are supplementary, equal 180 degrees, and I know this angle plus this angle plus this angle add up to 180 degrees, or I know that angle 2 and angle 3 together are 90 degrees. So May-Lin is installing shelves in her room. One of the brackets she chooses for her shelves is shown. The measure of angle 3 is 55 degrees. What is the measure of angle 4? Well, again, these two form a straight line, so I should be able to, right here, angle 3 plus angle 4 equals 180 degrees. And what do? We supplemented what we knew for angle 3. We ended up subtracting 55 from both sides, and then we knew that angle 4 was 125. So, in general, that's about the most challenging math that we'll be doing in this class, generally. Between those two examples right here, just understanding your definition, do some substitution, and solve. Let's see here again, not too worried about this, but looking at the check. The city planner is designing an entrance ramp for a freeway, and the design ACD, not to be confused with the band, ACD is 45 degrees. What is BCA? Well, again, both of those angles added together equal 180 degrees. So this should be 180 minus 45. And that equals 135. So again, being able to look at the information using our definitions, things that we understand. Okay. Continuing on here, congruent angles, again, angles that are congruent are the same angles. Reflexive properties, some of these properties we often use without even thinking about it. This, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. We often do that without even thinking about it. If I were to solve an equation that is, if I had 2x plus 5 is equal to 5x, I may turn around and subtract 2x from both sides. And I have 5 is equal to 3x, divide both sides by 3, and then x is equal to 5/3, or often we will just simply reverse it and say, well, x is equal to 5/3. We're able to switch that because they're equal, and that's what they're doing with the symmetric property. The transitive property, again, we can do that mathematically. Here, it says that if angle 1 is equal to angle 2 and angle 2 is equal to angle 3, mathematically, angle 1 equals angle 2, and then angle 2 is congruent or equal to angle 3, well, I can substitute. Right here, if angle 2 is equal to angle 3, then I can simply substitute in for angle 2, angle 3, because they're equal. Okay, so let's see, not too worried about going over the symmetric property in definition form, but let's look here, congruent supplemental theorem. Okay, if angle 1 and angle 2 is equal to 180 degrees, and angle 2 and angle 3 is equal to 180 degrees, then angle 1 and angle 3 are equal. Okay, thinking about substitution, when we would solve system of equations, if we would often say that they're equal to each other, we would say that y is equal to 2x plus 5, y is also equal to x minus 3. So we would turn around and substitute and make them equal to each other since they're both equal to y, and we would say 2x plus 5 is equal to x minus 3, and then we would solve. Okay, that is basically what you can, with this property here, we can turn around and say, well, heck, if angle 1 plus angle 2 is equal to 180 degrees, and angle 2 plus angle 3 is equal to 180 degrees, well, then I know that angle 1 plus angle 2 is equal to angle 2 plus angle 3. This is mathematically doing it, and this is what really throws people for a loop, but makes a lot of sense too. Combine like terms. We have a angle 2 on both sides of my equation, so I'm just going to subtract angle 2 to move it over to the other side, but when I do that, it cancels out because angle 2 minus angle 2 actually becomes 0. So then I have angle 1 is equal to angle 3. So mathematically we're able to prove that supplemental, congruent supplemental theorem. And we can do the same thing here with complements. We can do the exact same thing here with complements. And then vertical angles. If two angles are vertical angles, then we know they're congruent. We've already worked with this over and over again. Angle 2 is congruent to angle 4, and angle 1 is also congruent to angle 3. There you go. Little things like that. Okay, so moving on. Again, not too worried about this information, but if we look at just what do we know, congruent supplemental angles, I know that that is 90 degrees, ABE. I know that DBC is 90 degrees. Okay. I know that angle DBE is equal to itself in both of these angles. I don't know what it is, but I know that this angle is equal to itself, that means that this is the remaining leftover part. That they both have the same little bit of leftover. I don't know what it is, but we could just simply say, hey, that's it. And if I wanted to maybe put some numbers in here, make it a little bit easier maybe. Again, if I just say that DBE is 50 degrees, then this angle right here should be 90 minus 50, or 40 degrees. This angle right here should, because of that 90 degrees, should be 90 minus 50, which equals 40 degrees. So therefore, those two things are the same angle measurement. So that's what we're talking about here, just being able to use these things. And then I want to prove here that angle 2 is the same as angle 3. Okay, well, let's see, it tells me that angle 1 and angle 3 are supplements. Well, I know that angle 1 and angle 2 are supplements. So if I plug some information in here, if angle 1 and angle 3, angle 1 plus angle 3 is equal to 180 degrees. And then I know that angle 1 plus angle 2 is equal to 180 degrees. And it wants me to prove that 2 and 3 are the same. Well, they are, because angle 1 is something they both have in common. But if I wanted to think about it, let's just plug in a number. Pick a round number here. Let's see. We'll call angle 1 60 degrees. Well, then I know that 60 degrees plus angle 3 is equal to 180. Subtracting 60, and then angle 3 is equal to 120. I also know that angle 1 plus angle 2 is equal to 180 degrees. 60 degrees plus angle 2 is equal to 180 degrees. Subtract 60 from both sides. Angle 2 is equal to 120. So there you go. Just being able to come up with that information. Sure, paragraph form, we can talk about it, but just using our definitions and thinking about our images. Let's see here, vertical angles. Prove that 2 and 3 and 4 are congruent if 1 and 2 are congruent. Wow. This one's a little bit a little trickier maybe. It says that angle 1 is equal to or congruent to angle 2, but I also know that angle 1 plus angle 2 should equal 180 degrees, right? So that means we're going to find out that there are right angles, but that's a linear pair, right? Supplemental, so that means they're the same. So if I say, hey, this is x, then angle 2 must be x, and they're equal to 180 degrees. 2x is equal to 180 degrees. If I divide both sides by 2, and then I find out that x, or angle 1, is equal to 90 degrees. So there, we're able to figure out that that's 90 degrees, and that's 90 degrees. And it wants us to prove that 3 is equal to 4. Well, again, we have discussed earlier that if you have one right angle, you have 4 right angles. But just think about it. These two add up to 180 degrees, so that's got to be 90 degrees. These two add up to 180 degrees, so that's got to be 90 degrees. And we're able to prove that 3 and 4 are congruent. Okay. This one, given that 4 is congruent to 7 right here, given that's the first thing to do. It wants to prove that those other two angles equal each other. Well, this, again, vertical angles, 4 should be congruent to 5. Vertical angles, 6 should be congruent to 7. Well, if, according to our arcs, 6 is congruent to angle 5. There you go. You can plug numbers in there if you needed to. You know, if 4 and 7 are 40 degrees, that would make 5 and 6 40 degrees. So sometimes putting a number in there will make it easy. Right angle theorems, let's see. We've probably covered these. perpendicular lines intersect at the form of right angles, which we saw up at the top example. All right angles are congruent. Makes sense. A right angle is equal to 90 degrees, so they're all equal to 90 degrees. It makes them congruent. Perpendicular lines form congruent adjacent angles. That's true because perpendicular lines intersect at a right angle are 90 degrees, so therefore both angles that are formed are 90 degrees, which is also up at our top example. If two angles are congruent and supplementary, then each angle is a right angle. Absolutely. Up at the top of the page, we just talked about that. And then if two congruent angles form a linear pair, then they are right angles. Absolutely. We just talked about that at the top of this page. So those are things that we now know. I mean, it's just we can use those and understand those in our definitions. Let's see here. Right angle theorems and proofs. Again, if angle 1 is congruent to angle 4, we just talked about that. If they're congruent, then we know that they are both 90 degrees. That was we just worked through that on the previous example. And then prove that angle 1 and angle 2 are right angles. Well, angle 1 and angle 2, well, if these two were equal, we determined that they were 90 degrees, then by definition 90 degrees is a right angle, or right angle is 90 degrees, and we know that angle 1 plus angle 2 is equal to 180 degrees, so if we subtract angle 1, we know that angle 2 is equal to 90 degrees, just like we talked about on the previous page. So there you go. We don't need to go through this laundry list of steps. Just being able to understand using our definitions of congruency and supplementary and vertical, those are going to give us what we need. And let's see here, proof. I'm not going to worry about the proof, but let's look at the angles. This tells me that angle 1 is congruent to angle 4, okay? So this angle and this angle are congruent, and that tells me lines J and K are perpendicular. Well, that tells me if they're perpendicular, they intersect at a 90-degree angle. If they intersect at a 90-degree angle, then I know that angle 1 and angle 4 are both right angles, 90 degrees. And they want me to prove that angle 2 and 4 are congruent. Well, again, this is 180 degrees minus angle 1, which is 90 degrees, so angle 2 is 90 degrees. Well, angle 4 is also 90 degrees, so therefore they are congruent. Don't care about this. I want to make sure we just understand these great terms and definitions. So with that, we're going to move on to our assignment, but making sure that we just understand our definitions will be the key, because we are definitely vocabulary centric in geometry.